What's going on, everyone? AMR back with another YouTube video. So in this one, we're going to be covering Python. So I'm going to be starting up a playlist here where you're going to start off with the bare minimum basics of how to do some of like the nice to haves in Python. And then by the end of it, you'll be able to have a fully fledged application that can be hosted, whether you want it to be in AWS, Docker, wherever. We're going to cover both of them. So the playlist is going to start where you basically are going to have a skeleton of basically nothing, which will be this episode. And it'll, by the end, you'll have that full-fledged application. We're going to be covering three things. So the first off is going to be data types. Second one's going to be DocStrings. And the third thing is going to be exception handling. So these are going to be very, very important for how you lay a strong foundation for the rest of your programming in Python. So let me just take a step back and talk a little bit about what this series is going to be really trying to accomplish here. So when I say that we're going to be starting a playlist in Python, I really want this to be more of a, you have an understanding of how to program, and syntactically, you want to achieve this in Python. Python is a very lightweight language that can be easily like, hey, I want to get an API, but I don't want all the heavy lifting of the dependencies and like Gradle and Maven and all that kind of stuff, what you have to do with like a JVM. Python is like, hey, just let me spin up a little thing of like Flask. It's going to be way less secure. It's not going to be like production savvy. I would say a lot of like higher end enterprise corporations try to stay away from like a Flask, or I mean, Django's okay. It's kind of like the supplement to Flask. But that's a topic for another day. So I've went ahead and prepared a couple of files for us. So the first here is going to be Docstring. Basically what I'm going to be doing is I'm going to answer 1 to 3 questions before we jump into a couple examples down below. I'll have a couple of sections where we can pause and you guys can feel free to answer them if you want or not. I don't really care. And then I'll be providing the answer. All of this Q&A portion will be in the description down below. So please give that a look if you want to follow up with how I answered things in the past. So for our first question here, we have, what is a good use case of having a docstring? It's a very good question. So docstrings are extremely important when you are writing out methods at like your main work. Okay, so like you're going to be on a team of 5+ engineers where you're all going to be working on different things, and a lot of the time you want to be able to go on vacation. Well, you can't have code that you writ and expect someone else to come in and just figure out what you were thinking at the time of. That's where the docstring comes in. It's basically like giving a high overview of what this method, class, whatever you have it, is trying to do. So there's 3 main things that make a good docstring. The first off is, does it give a high level overview of what you're trying to accomplish? The second thing is, does it cover all of the parameters being passed in? And third, does it cover the return type of the method or class that you're trying to accomplish? If you have those 3 things, I think you have a pretty solid baseline for what a good use case of a docstring is. So for our next question here, we have, what qualifies as a useful docstring? So that's kind of a different question. It sounds very close and similar to the first question, except this one is talking more about like context. So like I said, you're going to be on a team of people. You're going to need to understand how others communicate with one another, existing patterns you have on your team, and just trying to understand when you're not there, they're able to understand it. So although the first question kind of covers like 1, 2, 3, very like logical approach of what you need to do, 2 is more of like the behavioral thing. So when I go and I talk to other engineers in my team, I try to understand how they understand code and then cater to that. So I'm a big proponent of patterns. If something is patterned in code, don't shy away from pattern. In a perfect world, we'd all code the exact same way, and we'd be able to just contribute without any type of pushback. So what qualifies as a useful docstring is one where any one of the engineers on your team can come in and say, yes, this is exactly how I would have written it, and that's how you develop code that is sustainable for a very long shelf life. So for our third question here, we have, if you have a docstring, do you also need a type hint in the function declaration? So this is kind of a hot debate in the Python community. So in case you don't know what type hinting is, so type hinting is a way for Python developers to hint at what the type is that you're passing in and returning. So Python is not a typed-based language. You can just have a variable set to whatever you want. It could literally just be like x equals whatever, and then Python will interpret what the value or the data type is of the variable once it gets instantiated. So what type hinting does is when you're developing code and you raise a PR, it allows the other engineers to better understand when they're reviewing your code, hey, this looks like you are expecting a dictionary, but it doesn't really look like in your code that you're doing anything with like a dictionary data type. Is this correct? Did you mean to say like a set or an int? It's just like a really nice way to be able to help others understand where you're going and like what you're thinking. So in this case specifically, like, do you need one in the function declaration as well as in the docstring? It's a very, very good question. In my personal opinion, I think that you do not need to double down. So if you have one in your parameters, then it's totally fine. You don't need one in your docstring. Now, if you leave it out of the docstring, I still want you to be able to give a brief overview of what that parameter is doing. You just can leave out the type. So I'm going to also strongly encourage you to do type hinting over docstring. So by that, I mean, like with other languages that are typed, you're going to need to declare what type of variable that is in the like function declaration. So it might just be good to stay in that practice of type hinting and then leaving it out of the docstrings. Docstrings are kind of like a nice to have in Python. But realistically, outside of Python, I think you're going to get more use out of just keeping that existing muscle memory of typing out your variables. And then for our last question before we jump in here, we have, are docstrings required at corporate companies? So outside of college, I have worked at 3 corporate companies. Of the 3 corporate companies that I worked at, I think 2 of them did not require it, but this one that I'm currently at now does. And so, I mean, it's tough. It's really dependent on what type of company you're working for. In my personal opinion, it should be required everywhere. I just feel like documenting your code is just as important as writing your code. So if I were to give you a straightforward answer, I think that the bigger tech companies are looking for engineers that can develop very, very strong solutions while also being able to document it for longevity purposes. So now we're going to go down into like the code along section here. So I've went ahead and created a couple of functions and then a helpful little application class. So with this first one, I'm going to go ahead and give you an example of create app. And then in the get engine, I'm going to go ahead and give you what could be or could not be a good example. So you'll see what I mean in just a second. Just hang in there. But for this one, I'm going to give a brief overview. That gives you a high level of what this create app is. So app can mean a bunch of different things, but in this case, when I say automated programming interface, that in IT terms mean API. We all understand what that is. So then I'm going to go ahead and jump down into the config. So config is a param. I put the parameter in, I do the type hinting in like parentheses. However, you could also do the type hinting up here. It's to each their own. We're going to be covering how to type hint in a future video. For the purpose of this one, I'm just going to go ahead and put them in the docstring since docstring is the focus point of this. So anyone that comes in, they're going to know that config is a dictionary data type. And then as a high level, it's just a key value pairing of a configuration file being passed in that matches your secret names to their values. Easy peasy. And then down here, I have a nice like little return statement. Said, usually I do like Flask app or something like that. So there you go. That is a really, really good example of high level overview, what this create app does. You're not like blowing out the lines. No one wants to like read a novel. Like documenting is very important. However, you don't want this to be a novel. You're going to have thousands of lines of code in each file and like hundreds of files in an application. There's no reason for us to be writing Stephen King novels here. So I'm going to go ahead and give a high level overview of what I would write for this. And then I'm going to ask you guys to pause the video and tell me whether or not that is a strong or weak docstring. Okay, so here we have a high level overview of what Get Engine is. Why don't you go ahead and pause the video and tell me whether or not you think this is a strong or weak docstring. Okay, so for those of you that did, thank you. That makes for like a seamless transition. For those of you that didn't, not a big deal. So in this one right here, this is going to be a very, very weak docstring. So I can't really interpret what an engine is in this case. Literally, this makes no sense. And honestly, this is not exactly what you're trying to even do. Why would you say get engine and then use the word creates? It doesn't really make a whole lot of sense there. So in this case, the way I'd restructure this is, so now I have an understanding, okay, when I pass in con, I know what con is now. It's a connection string. And I'm going to use that connection string to turn back whether or not this is a live or stale instance. So con, we now know, is a string. So this could be whatever data source you're using, MySQL, Postgres, Redis, whatever. So going down to the class docstring, it's going to be a little different. So your class docstring should be very, very high level. It's going to be covering a bunch of different functions, but you're not actually going to go in depth of what those functions do. You're going to say, okay, what is this object's purpose to the overall code? Us as engineers, we try to minimize the amount of objects that we create on a grand scale. We're just going to be creating so many things that if we already have an object that exists in code, like application, what is the purpose of recreating it again? Why don't we just go ahead and do some inheritance and then add on to it with a couple of like adder functions and stuff? You don't really need to recreate an object. So the docstring of this is going to be really, really helpful for other engineers to better understand why this object needs to be created for our application to be working properly. Okay, so obviously this is not a real world application class. I'm just trying to get the point across that your docstrings between your functions and your class are going to be very, very different. In this case, the application, it's kind of just an object that'll be used to interact between the back end and the front end. In the real world, there'd be many different classes that would do this. I understand that. Don't flame me. But high level, that's what a docstring does for a class. So coming down here into your init. So your init's a little different. I do not think that you need to give an overview of what init is. However, I would strongly encourage you to list out like what the name and age, whatever attributes that you're trying to instantiate your object with. Give a little brief understanding as to why those attributes are needed to instantiate the object. Okay. I think that's a strong docstring for your constructor. Again, you don't need to do a return or a representation of what the constructor is. Every class needs one, so you can leave it out, but do try and do some type of a docstring around the attributes of the class that you're instantiating. So the toString, I'll leave it up for you. Again, this doesn't have to be like something you have to do. In my eyes, I don't think you even have to do a docstring here. Again, this is how, when you want to print an object, that the object gets printed out. Otherwise, it just gives you a representation of what the object is in memory. So it's up to you. You don't have to. And then down here for read query. So I haven't showed this off yet, but there's a really, really cool feature inside of PyCharm where if I just do the triple quotes like this and then I hit enter, it auto populates. So this is really, really cool. So the way I was doing it before is I just had the triple quotes before I actually did all the classes and stuff. So I wasn't able to do the magic behind the scenes. So I added on this little part right here about creating a connection and terminates the connection post transaction. All that means is like whenever I'm doing the read query, I'm going to instantiate a new class, or not a new class, a new instance of the connection object. Go ahead, fire it off. And then once that comes back with my query, go ahead and kill off the instance. Perfect. All right, let's go ahead and jump on over to the data types. All right, so for this next portion, we're going to be covering data types. I only have one question on this one. I think data types are a very like computer science language independent concept, but just the general purpose of laying a strong foundation, we're going to cover over how you do the instantiation of different data types in Python. So my first question here I have, is Python a typed language? So obviously Python is not a typed language. You do not have to say int x equals 12. You can literally just say x equals 12. Python's interpreter under the hood is going to be able to understand what the data type is of that variable once it gets a value to instantiate the variable. So for our examples down below, I have what are all of the different data types inside of Python. So you have your standard string, int, float, boolean, list, set, dict, and then I have a bonus one that I'll save until the very end here. There are a plethora of other types of data types. These are the core data types. I think I'm leaving out tuple, but To each their own. I'm not going to cover it. If you want to look it up more, that's totally fine. But for the purposes of just keeping this more concise, not trying to beat a dead horse here, let's go ahead and do a quick couple examples of what these data types look like. So for our string, a string, for those of you that don't know, is literally how we communicate as humans. It's a sentence. So this is how you would do this. You would put it in a double quote. So there's many different ways that you can write a string in Python. You can either write it in double quotes, you can write it in single quotes, or you could write it in triple quotes. This is really, really cool. I mean, there are other ways you could write strings in Python. I mean, Python is super cool in that way, but it's also kind of like, why are all these different methods existing? There's answers out there. I'm not going to go into them. But general, high level, these are all acceptable ways to write out a string. Before I jump over to the next part, I do want to talk about how you can typecast to a string. So let's say that you had a equals 1. You wanted to typecast a as a string value. They have a built-in function, they have a built-in function called str, which is in the Python standard library, where it converts whatever object you're passing it in and translates that into a string value. If it does not have a proper object being passed in, it does give you, I think it's a value error or a type error. Feel free to check me up on that one. So next up we have int, as mentioned above. An int is basically just an integer with 1, 2, 3, 4, whatever number, whole number I should say. And yes, they can be negative. Is going to be quantified as an int. In like-minded terms, we have a float, which is a decimal ended point. So these are floating decimals, I think is the term for it. But anything that has a decimal after it is going to be considered a float. There are other data types, long, double, all that stuff, but I don't necessarily know if Python does anything for those specifically. You might actually have to like create your own type of subclass of them or figure out a different way to do it. I've never had to do it, and I've been programming Python for 7 years. Booleans are just going to be your binary transactions, true or false. So it's kind of funny in this case, C is actually equal to true, and this is actually a plausible way to write out a clause to a variable. So Python does left to right comparisons, and it's going to say true or false. This is true, so the statement's true. This is actually like an acceptable way to write this variable out. It's kind of crazy. But for general purposes, you have C is true, D is false, and those are basically your two Booleans. Now, it's worth mentioning that none type is not actually a recognized type in the standard library of Python. However, when you do instantiate a value as E equals none, it is of the type none type. Now, it is worth noting that if I go like this and I say E none type, it's going to say it doesn't know what none type is. It's super annoying, and I strongly recommend you to just go like this and print out what this is. I guarantee you it says none type. I don't understand why. If for those of you that do know, feel free to put down in the comments, because you'd save me a world of headache. I've just never gone through the effort of looking it up on Google. Next up, we have one of the favorites. It's a list. So a list is kind of like a bucketing approach or an array in other languages. So let's go ahead and instantiate this with an empty list, and then let's go ahead and fill the list. So append adds things to the very end of your list. So if I do append 1, f append 2, I print f, this is going to look like this. So then I'm going to go ahead and do f.remove 2, and now your value will look like this. So the dot remove and dot append are going to update the state of the object. That's basically what a list is. It's an object. So whenever you do append, it's updating the state of the object with that attribute having 1 filling the stack there. And so when I do the dot remove, it removes the 2. What the remove does is it looks for elements that have this value here and then removes them. It is worth noting that it is only going to remove the first one that it comes across. So a lot of the times, if you have multiple of these, you'll actually have to put them in a while loop, while 2 in this list, f.remove 2. If there's a better way of doing it, again, I strongly encourage you to put it down in the comments. It saved me a world of hurt. I've never had to look it up. So sets are a really cool way. They're a lot like lists, except they're immutable, and they do a lot of deduplication. So let's go ahead and say G equals set. By the way, you have to instantiate a set like so, or you could have it be something like this. It's very similar to a dictionary. It kind of pains me. I really wish they would have done something else for this. I think that you'll see down in the dictionary portion, but if you wanted to instantiate a set in real time and you knew what those values were, you do it as such. Otherwise, you do it as the way you do G, and then you do G.add1. Now, it is worth noting if you do add 1 again, the G is still just going to look like this. It's not going to add 1 because 1's already in there. Whereas if I were to do that in the list, it would just be 1, 1, 1. It just keep adding and adding and adding. Whereas a set, if it's already existing in there, it's not going to re-add it again. And now we have one of the favorites. It is a dictionary. So I'm going to go ahead and say I is equal to AMR. He is a creator. And then we have YouTube, which is a platform, if I can type it. So whenever you're trying to delete a key inside of a dictionary. So for those of you that don't know, dictionary got its name from the actual Webster dictionary concept. It is a hash map, similar to how we have a Webster dictionary. Every word in there has a pairing to a definition of that word. Now it's worth noting that you're never going to come across the same word twice in a dictionary. Same is true here. If you do have 2 keys of the same value, whatever one that you instantiate last overwrites the existing one. So here we're going to go ahead and say del, which is going to be deleting a key as long as the key exists. And then if I were to print out what I would be, it would look like such. It would look just like this. And then the way to add one back after you've already instantiated your dictionary is AMR equals creator. So now you have it back to square one. Now my favorite part is talking about eval. Eval is one of the coolest things in Python. Basically what this does is you don't necessarily know what's being passed in. A lot of the times whenever you're using a console to have like an input allowing user interaction, so at that time you don't know what they're going to pass in. You could use the eval built-in Python standard library function that actually takes in an input as an object and then tries to identify what data type that is and convert that for you. So the main reason why it has a big problem trying to identify a string as a data type is because it actually tries to take it as a literal. So then when it tries to read it in as a variable, the variable is obviously not defined yet because it's input. And then it goes, I don't know what you're talking about. So that is the main reason why eval has a hard time interpreting string values. Let's go ahead and jump on over to exceptions before we wrap up today's video. So next up we have exceptions. So we have 3 questions here before we jump into a rather lengthy example. Again, this is going to be a quick understanding of how to write out the error class, exception class. Hint, hint, I do override the built-in exception data type. To each their own, you know, you can do whatever you want. I went ahead and did this for like general YouTube purposes, but by all means, I encourage you to just take it for what it is and then try to get the most out of it. So for our first question here, we have, when should you be handling exceptions? So literally whenever you are going to depend on some type of logic that could raise an exception, you need to be catching the exception. The last thing you want is to have an application hosted somewhere and then being like broadcasted to the greater world, and then it gives a 500 error because you didn't catch an exception. That is the worst case scenario. So whenever something has the opportunity to raise an exception, it is a fantastic time to catch the exception. So the way that we do that is we do try catch inside of Python as like a generic purpose. There are other ways to handle that, but for the general purpose, we do a try catch. So for our next question, we have, how exhaustive should our exception handling be? So that's a very good question. I think that it's very dependent on the patterns that exist at your company as well as the other engineers on your team. I think that as long as you are providing some type of context that is going to make sense to whoever's on call to better understand what the exception is and where they can go about finding where it is. Now, a lot of like logging systems have built-in functionality that will spit out the line number and the file name, as well as like the working directory of where it lives. That's fantastic for exception purposes. The exception should be somewhat descriptive of what the exception got thrown by. Is it a value error? Like what value made the value error pop? Those kind of things. So for our last question we have, is catching all exceptions by a greater generic exception fine? Absolutely not. You never want to bubble up all of your exceptions into just one larger generic exception. So like, I understand that it's a lot more work to have to like go about catching all these different types of exceptions. And realistically, if you're writing an application that is going to feed downstream to a bunch of different other things, and you just want to like, hey, I am the source application, meaning like everything flows downriver from me. If I want to give back a singular exception, that's totally fine. I completely understand why you would do that. However, if you're writing an application that is depending on other applications, you need to be able to say like, okay, I tried giving it this, and why did it bomb out? Like, what did I do that was wrong? And so you need to be able to, you're going to need to be able to differentiate the different types of exceptions so that way you can better understand when debugging where the issue lies and how to go about fixing it. So I went ahead and created a rather exhaustive type of exception handling. So I actually have a lot of this like currently in place in a personal application that I wrote. Basically, I have a class right here called error, and I have two different types. I have your client-based exception handling and your server-based exception handling. For those of you that are familiar with how HTTP error status codes are represented, a lot of these are bulked into a specific HTTP status code, so I can better understand when I'm communicating with my API what happened and how to relay that back to consumers. So that's basically what this is. Client-based exception handling are going to be your 400 based types, and then you have your 500 based type, your 500 based HTTP status error codes. There are 100, 200, and 300 status codes. I am not very familiar with them. I've been, like I said, working in Python for 7 years, building out APIs, and I've never really had to communicate with like a 100, 200, 300 error code. They do have value, don't get me wrong. However, for general purpose applications, especially in the playlist that we're creating here, you do not need to know 100, 200, and 300s, but I strongly recommend you check them out. So for our next up, we have our exception class. So this is going to be overriding the built-in base exception class that we have in Python. So here I'm just going to give out a generic skeleton of what I want my error generator to look like. It is just going to be a way to give back something in the response body for my API without having to do a bunch of conversion between JSON and all that kind of stuff. So down here we have every time that we're creating an exception, we're going to go ahead and pass it into that error gen. We're going to be using the name of the error, what caused the error, and then a general message if we want to. So you notice that some of them actually have parameters being passed in and others do not. So in certain cases, it's not always a good thing to be exhaustive with your logging. So the unauthorized and the forbidden are pretty much exclusively resulting in security errors. So whenever you're doing a security error, you do not want to be descriptive to whoever's communicating with your client. You want them to just go ahead and figure out what the problem is on their own, just in case they are a hacker. You don't want them getting too much information and figuring out what the problem is. So in this case, I'm just going to throw a base unauthorized exception. Don't even give them really much to go off of there, and then return it back. In other cases, like an invalid value, you know that they've already like authenticated to your application because you have some type of decorator protecting the overall state of the state when they're trying to go into like your deeper methods. Invalid values should only be returned when they're already authenticated to your application. Therefore, you can be a little more descriptive. The way that I'm doing this is I'm actually using the enum up here as I showed. So by using auto, we have a .name attribute, super cool because it just takes whatever the name of the variable is and assigns that as the value. Super cool. I really, really like that. I think that it's very indicative of what this error represents. So it makes sense. And then as you might be able to see in a couple of them where you have a MSG being passed in, so that gives the flexibility to where if you have different types of value errors raised in a singular method, this allows you to pass in a message that would differentiate the different types of value errors that you're having. So that way, in case like it fails up on line 3 compared to like line 81, you'll be able to understand what exactly was the problem. Was it a value error because you're passing in a list, or is it a value error because we were expecting to do something with this data set and then you passed in something wrong. But that's going to do it. So in this video, we covered DocStrings, data types, and exceptions. So in the next video, we're going to be covering 3 things yet again. We're going to be covering, first of all, we're going to be covering type hinting. The next one we're going to be doing decorators. And then the last one, we're going to be talking about a package called subprocess. Really, really cool thing. And I hope to see you in the next one. See ya.